So we're going to talk a little bit about negative etchback and what it means. One of the things we want to understand is what happens, with negative etchback. What is it, first of all? Is it acceptable? And what other issues can it potentially cause? And then we're going to go talk about roughness and plating nodules. These, again, can be considered nonconformances, but in many respects, they are process indicators. And we're going to give you some actionable items on how you can prevent or minimize both of these so you don't have significant yield loss. So let's look at negative etchback. And this is what happens in negative etchback. As you know, we strive to get in the multi-layer board, after drilling and with D-smear, we try to get what we call a 3-point connection. But sometimes, depending on the extent of the D-smear that's done, how much resin is removed, and the fact that these higher performance resin materials don't etch back as well as some of the lower T sub D materials, one of the things that happens is during the processing of the multi-layer board, either through the micro etches on the electrolysis line or in the area where we actually run the panels through a permanganate D-smear process where we have a neutralizer based on hydrogen peroxide. We end up getting some copper buildup in that neutralizer, which is important in the permanganate process to remove any manganese dioxide residues. But that starts to etch back and remove some of the copper from the interlayer foil, and you end up getting an indentation. Now, by and large, the IPC 600 acceptability of printed wiring boards allows a certain amount of negative etchback. But I wanted to bring it to you because you could have excessive etchback, which is going to cause other issues potentially for air entrapment, plating separation, etc. So you do have to ensure that you don't have excessive negative etchback. That's why I always prefer to get at least a 3-point connection, even if it's 1 to 2 mils of etchback, as opposed to this situation here. And just for your own knowledge, it seems like 1/2 ounce thick or heavy foils will have more of an issue with etchback, negative etchback, than the 1 ounce and up copper foils. Not sure why, it's just one of those things. And here's a good example of what happens when negative etchback exceeds basically, 0.025 millimeters or 1 mil. It gets too deep, and this situation happens here. You get plating folds, and you have air entrapment. This, of course, would be considered non-conforming. And if it's non-conforming, obviously, this is a rejectable condition. So you definitely have to go back. This isn't a plating problem. Don't expect your copper plating to fill this area in when it's this deep. This isn't a drilling problem either. It is not getting sufficient D-smear or removal of, during the etchback process. But more importantly, the copper is being etched away in one of the other processes in the line, either the permanganate neutralizer step or in the micro etch prior to electrolysis copper. So again, look at your copper removal etch rates to make sure that this is not happening, in an excessive manner, because this will happen. Particularly, you see here, this is a 1/2 ounce foil. You can see how it etched back, and that is, again, a significant problem. So this is a non-conformance when it exceeds 1 mil, and try to keep it down to that. Another area that's very disconcerting for everybody is good old plating nodules. When plating nodules basically show up as rough spots, high spots, and they can be on the surface, they can be in the hole, they can be seen pretty much anywhere, and typically they're random. And when I see this type of situation, it is definitely a severe process indicator. It tells me that some of my mechanical aspects of my process, in other words, filtration, agitation, keeping the solutions clean of debris, of metal pieces, filters, all of these can cause roughness. These materials get basically pushed onto the surface of the pad or inside the hole, and we end up getting rough plating that you see here. Now, it's not just the fact that it could be materials that are causing this. It could be also, and we'll talk about it, the plating operation itself, not leveling out this area here. But always when you see something like this, particularly when it's random like that, start to look at your filtration systems. Are we removing debris cleanly from the plating solutions? Because to me, all plating solutions should be continually filtered through a 20 or 15 micron filter system to keep the plating solution clean as possible, because you don't need to introduce, material or stray materials that could cause you roughness that you see here. So they can come from a number of areas. Some of them you'll see be quite surprising, but it could be, and we talked about in one of our previous podcasts, surface imperfections, the copper foil. The copper foil itself could have some rough spots in it, some debris on it from the incoming material. If you don't see that, you're going to plate right over it and you're going to get nodules. You can also see it from any organics in the plating room, in the plating solutions themselves. It can cause from metal that has formed into the plating solution and not filtered. So the inorganic metals like copper ions or copper fines and even nickel plating can cause these rough materials to get reincorporated back onto the surface, and you plate over it and you get roughness. Now, one of the things you're going to see here, you look at this slide right on the top, you can see this really non-uniform debris here, nodule. So there was some debris there that was not filtered properly. It formed in the solution, ended up getting incorporated or pushed back onto the surface of the circuit board, and you can see the plating actually plated over it, giving you this type of situation. So this is more of a debris type of filtration issue. But yet there can be other areas that lead to nodules. One of these is seen right here called edge effect, where we see nice smooth circuit traces in the copper plating, but just on the edge, we start to see a little bit of roughness, as you can see right here. It's not bad, but we can see it. I call it edge effect for lack of a better term, but it could be a number of reasons. It could be some photoresist residue that wasn't developed properly during the developing process. It could be because of overexposure and underdevelopment. That's a possibility there. Resist lock-in. So you have to check that out because the rest of the lines look really nice. There's no pitting elsewhere. So what I would do is I would take a look at the plating solution itself, the acid copper plate. Am I getting good leveling? Is my additives, my organic addition agents to give me the type of brightening and the leveling that I need, is it actually out of balance or too low? Typically, when you see edge effect like that and it's uniform nodules around the edge, this is one of the first places I look. So edge effect, high plating additives, or imbalance in the key levelers often lead to situations like that. Now, this is very interesting. This is a surface, obviously, you see here, and you can see the debris right here, clearly. Copper plate going to plate right over this junk. And what is it? Well, it could be anything. It could be filter fibers. It could be brush scrub fibers. It could be things that haven't been filtered out of the plating solution. It also could be redeposited photoresist from the developing operation. And actually, in this case, when we actually did the troubleshooting, and you notice that the amorphous shape of this, by the way, this is just a larger view of this. You can see the debris that has been incorporated in here from lack of developing and poor filtration of the developer solution. So this is like extra resist particles that were developed away, the unexposed resist, and then it was pushed back onto the plating surface, and the copper plated right over it and around it, and giving it this very nasty look to it. One of the things you got to be careful about when you are developing your photoresist is to ensure that not only you have good filtration of the resist being developed, but make sure that the nozzles aren't plugged and the nozzles aren't redepositing or spraying this unpolymerized resist back onto the plating surface, because that's going to be a real issue. One of the things that I always look at too is the resist loading. I follow your photoresist supplier's recommendation to make sure that you're not overloaded with photoresist and you're using the proper feed and bleed system to keep the developing solution as clean as possible and not overloading it with resist. Now this one's very interesting. This is something that you may or may not have seen, but you can see this. You can say, oh, it's got to be filtration. Well, in this case, it wasn't. It was caused because of algae. Algae forming in the rinse waters and in the plating tanks. Yep, algae. And something like that due to sulfur contamination, plating solution issues, even the water lines within the printed circuit board fabrication itself was introducing some algae in the rinse water. And the algae was actually forming back onto the circuit, and you were plating over it. So when you see something like that, yeah, filtration is important, but you're going to have to clean out your lines, probably use some bleach to kill the algae, and make sure that your water quality is very, very high and devoid of any things like algae, et cetera. So keep that in mind. This is a possibility, and typically in warm weather, yeah, one of the things that we typically see this in the plating solutions and the rinse waters.